4.6 is graphing of other trig functions. We are going to look at tangent, cotangent, secant, and cosecant. And today we're going to focus primarily on the graphing of secant and cosecant because those ones fall most in line with sine and cosine. So hopefully you'll find those quite easy today. All right, just a reminder that cosecant and sine, remember that starts with an S, the S in the middle, they're reciprocal functions, okay? So when you have 0 for sine at 0, if you would do the reciprocal, you would get, this is like over 1, so you'd have 1 over 0, which we know doesn't exist, therefore it's undefined. If we then look at pi over 2, because remember we're just looking at those 5 points that are the easiest 5 points, the quadrantial angles. The reciprocal of 1 is 1. The reciprocal of 0, again, is undefined. The reciprocal of -1 is -1. The reciprocal, again, of 0 is undefined. And if I look at those points that aren't so friendly, the reciprocal of 1/2 is 2 over 1, so that's just 2, and so on. You can look at the rest. Now, let's graph this and see what this looks like. Again, a reminder, we are graphing the cosecant function, so we're graphing this one right here, and this is our independent. I have the x, really I should say the independent. So this is the independent, this is the dependent. Okay, so starting at 0, we have undefined. Well, undefined is an asymptote. So we're going to have an asymptote here. And let's go ahead and put all those asymptotes in. We have one at pi and one at 2 pi. So look at that. Every other one is a vertical asymptote. And let's look at those points in between. So at pi over 6, we have 2. At pi over 2, we have 1. That one's pretty easy. Pi over 6 is somewhere over here. So we'll put that like right here. And then at 5 pi over 6, so that's somewhere over here, we'll put that at 2. So it looks something like that. And as we continue with this into the next section, we have 7 pi over 6, which is going to be right about here, and that is -2. And then we have at 3 pi over 2, we're at -1. And at 11 pi over 6, that's almost pi, we're at -2. So we have this. And I'll just show you what this function looks like is because we know we can't touch the vertical asymptotes right here, these are going to connect and get really close to the asymptotes but never touch or never cross them. Likewise, it's going to happen here. So they're little parabolas that are in between each of the vertical asymptotes. And if I continue this pattern without looking at a table, well, every other one was a vertical asymptote. So this would be, and this would be. And that one, that maximum or minimum, turns into a maximum or minimum point, and it was halfway in between the asymptotes. So this is, oops, I drew that in the wrong spot. That was, it's alternating. As you can see, I have a minimum here, maximum here. So this is not here. This is actually down here. My bad. And then we're going to alternate again. So halfway in between there at that value of 1, we have a maximum. So this is what a cosecant graph looks like. Now, we don't want to graph all these by creating tables. So instead, I'm going to show you the shortcut. And the shortcut is to graph either the sine or the cosine function, the reciprocal. So let's start with that because we're really good at that. We know, and let's just do a sine because that's what we did. So we know a sine has a maximum of 1 with no transformations, a minimum of -1, and here's where our midline is with no transformations again. We also know that a sine begins on the midline and every other point is on the midline. And we also know when it is positive that it's going to increase before it decreases. So we have an increase here and a decrease here. And following the pattern, I have this. If I were to graph a sine function, it would look like this. And that's how I'm going to start all of these graphs. I'm going to graph the reciprocal. Then I'm going to draw in the vertical asymptotes. And that's where the zeros are, Okay, so you can see where the zeros are in this function. It's every time you have a point that is on that midline. So then you'll add in the vertical or horizontal asymptotes right here. I'm sorry, vertical, not horizontal at all. And then you're going to sketch the parabolas. And what's going to happen is this maximum right here is going to become the minimum to the parabola. Because unlike when we're graphing a sine or cosine where it's inside the function, the secant and cosecant are outside. So here's a minimum there. This point that was a minimum is now a maximum. It's the highest point. And we're going to alternate, just like we did in the first problem. And that's how we're going to graph these cosecant and secant functions. So you can see here what it looks like. I have the red is the sine graph, and then you can see how I get my cosecant. And likewise with the secant, I have my cosine graph. Notice I started with the maximum here. That was my cosine, and again, graphing using those maximums and minimums, the parabolas in between the vertical asymptotes is what the secant graph looks like. So here's what we're going to do. We're going to start by graphing this secant function. The first thing you want to do is graph the reciprocal function. So ask yourself, secant is the reciprocal of what? And it's cosine. So you are going to graph the cosine graph like this. And you should be really good at that now. This one does not have any transformations. We have, I'm not going to make you fill out all those 4 key features because hopefully you are good at that and you can now do it without that. So we're going to find the midline at 3. We have an amplitude of 1, so we're going to go up 1 and down 1. We still need to do the scale, so 2 pi divided by b, and my b is 3. So this last point is 2 pi over 3. And when I multiply that by 1/4, what I get is pi over 6. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, pi over 2, and then the negatives. So nothing has changed so far. And now I'm going to graph that cosine function. It's a positive cosine, so I'm going to start at the maximum here. If I start at the max, I'm going to end at the max. There was no phase shift, so that's why I started at 0. Halfway in between is the midline, or I can just do every other one like this. And then following the pattern on the other side, it looks like this. Now I'm going to put a dotted line because this is not my answer, but that is what my cosine graph looks like. And now when I graph my secants, I'm going to use my shortcut. Every point that is on my midline right here is going to become a vertical asymptote. So you have 1 here, 1 here, 1 here, 1 there. Every maximum, this was a maximum before, becomes a minimum to the parabola for the secant graph. Every minimum becomes a maximum. So you're just going to make parabolas using the point there, the maximum or minimum, as the vertex. And you're going to go like this. And you should have a minimum of 3 parabolas, so either 2 up and 1 down, or 2 down and 1 up. Now I'm skipping quite a few, but I want to get to some with phase shifts. So we're going to jump down to this one. And this is a negative cosecant. So first thing you want to do is identify this is the reciprocal to a sine. So we're going to graph the negative sine function right here. And this negative 1/2 pi is the same as negative pi over 2. We talked about that before. That'll be easier with our phase shift. Now, again, I'm not going to worry about doing my ABCD, but I could, okay? My amplitude is this, midline is this, I have that phase shift, okay? Let's start with the midline really quick. We have a midline of 3. We have an amplitude of 2, so I'm going up 2, I'm going down 2. My function, my sine function will fit in between there, but my cosecant function will be outside of there. Now, my period is 2 pi divided by b. My b value is a 1. There's nothing, no coefficient in front of the x, just that 1. So that makes it easy. It's 2 pi. And it's our pi over 2, pi, and 3 pi over 2. just like on our unit circle, those four quadrantial angles. And now when I graph this, I have that phase shift. So I'm going to start at right pi over 2. So this is my starting point right here. And because it's a sine graph, it's on the midline. But it's a negative sine graph, so it has to decrease before it increases. So it's going to decrease first. If it would have been positive, it would have then increased first. So following the pattern, going both directions, this is what this would look like. Again, I don't care if you put the line in, if you dot it, do whatever, because bottom line is that's not our solution. We need this to determine where our vertical asymptotes are. And our vertical asymptotes are going to be where all those points are on that midline right here. So we're going to put vertical asymptotes there. And then we're going to create our parabolas with the endpoint here being a vertex. This has to open up. This has to open down, because remember, it has to be on the outside of those lines. There we go. Again, a minimum of 3. I have 5. I'm going to do one more for you, and then I'm going to let you try one, and then I'll give you your assignment. So this is a secant. So what we're going to do for a secant is graph the reciprocal, a cosine. It also has a phase shift, though we have to factor that 2 out. So what we're going to graph is this. 2 cosine, I'm factoring out the 2. That's dividing this by 2 and this by 2. And that's going to be plus pi over 2. And then it's plus 1. That's what I'm going to start by graphing. So my, go ahead, we'll get our scale. 2 pi divided by b, that's pi. And pi divided by 4 is 1 pi over 4, 2 pi over 4, 3 pi over 4, and then back to 4 pi over 4, which is just pi. Notice I just reduced my fractions to the ones that I could reduce. And now I have a midline. My midline is at 1. My amplitude is 2. I will go up 2. I will go down 2. My cosine graph will fit in between here, but my secant graph will be on the outside of there. And there is a phase shift. My phase shift right here is going left pi over 2. So I will start right here. Now, because this is a cosine and it's a positive cosine, I have to start at the maximum. So I'm going to start right here at the maximum. And because it is, well, there's only one way to go. You have to go down. You can't go up or you'd be outside. Again, we're ignoring that one. That was just to represent my starting point. So I'm just going to follow the pattern in both directions. And this would be my cosine function with the appropriate transformations. But from that, I can now create my secant on the midline right here. Every point here is going to become an asymptote. So I will have one right here, one right here. Remember, I crossed that one off. Here and here. And then my parabolas fit in between here going outside of the function. Maximum becomes minimums, minimums become maximums. I have to have a minimum of 3. I have 4. I'm good. I don't have to put this one here, but I could if I wanted to. Now, if you want to give one a try, I would recommend you trying this one. This is a negative cosecant, so you're going to start by graphing a negative sign. So if you want to pause the video, give it a shot, check your answers when you're done. This one does have a phase shift of pi over 4 going to the right. So be careful on this one. When you go to the right, you're halfway in between the 0 and the pi over 2. So all of your other points are going to be halfway in between here. And these are the points on your midline, which become your asymptotes. And your function should look like that. The answer in red, while it is kind of messy, that's what it should look like. All right, your homework is 4.6a worksheet, and you can submit it in the School Gym when you're done. Bye.